So what do we got now?
It's capital T in parentheses M equals M square root 2M minus B.
Minus B.
Yes,
Okay. So we got something like this. Um,
right.
well, let's see. Now, our product rule functions look like this. Actually, we should probably write this as an exponent instead of a radical, right? So that way we can do our calculus with it. So something like this, where we have it in parentheses with a what is that? A
1/2.
1/2? Yeah, that sounds pretty good. All right, so let's take a look here. So t prime, we stick this into our product rule. F prime, where that's just m, times 2m minus b to the 1/2, plus g prime, 2m minus b to the 1/2 prime times m.
Right.
All right. So what is m prime?
It would just be M.
The derivative of m?
Just M right now.
Well, we're priming it, right?
All right, it's 1.
1. There we go. And then what about this 2m minus b to the 1/2? What about that?
It's 1/2 in parentheses 2M minus B. Oh, and then one thing in the exponent is going to be 1/2 minus 1.
Right?
And I'm going to write it again. Oh wait, and then the M.
Well, be careful. Chain rule showing up again.
So we have to write again in brackets is 2M minus B. And
Right.
then
And the m just comes along for the ride. So let's see. 2m minus b to the 1/2 is fine. Plus 1/2 2m minus b. 1/2 minus 1 is
is negative 1/2.
negative 1/2 times. So what does this 2m minus b prime come out to be?
It would just be 2.
2 times m. Okay, it's looking pretty good.
Nick, I have a question. So
Yep.
we in the brackets where 2M minus B, So how come we're only doing it once? Like the other problem, we had to do it twice because they had the same, right? Common, you know, they're both the same, 2m minus b. That's why we only do it once, right? Like for this one, we have 2a's.
Oh, I see. Yeah, it's all based on how many times it shows up in the original function. So if we look like right here when we differentiate secant AV, that A only shows up once. So that's why our chain rule factor just becomes the 1. Actually, it's not even that one that I'm looking at. Um, there's our original one. We had secant of AV.
Right.
So that's why we get 1A coming off of it. Even though it does split into a secant and a tangent that both have A's, it's only the original one that the chain rule applies to.
Right.
Yeah. So it's the same sort of thing here. We don't have two copies of the 2m minus b floating around in the original function. So there's a single 2m minus b right here. So that's why there's a single 2m minus b prime.
Okay.
Yeah, that only really comes up when you're dealing with secants and cosecants. So that's really the only time you'll have to worry about something like that. Every other time it's just going to be once.
Okay.
All right, so let's simplify this then. We got this 2 and this 1/2. Those can go away.
Well, oh, okay. So we'll put the m in the front.
Yeah. So here's an interesting situation. How do we simplify something like this? So we want to factor, just like before. But the question is, what do we factor out? Well, we can see that both terms here have a 2m minus b. So we're going to pull out some quantity of 2m minus b's. But what's the exponent going to be the one we pull out? And then we'll have some stuff left over inside that we can deal with in a little bit. So let's just look at a side note example here. Like if we had something like, I don't know, 4x3 minus 6x5. Well, let's make that a 5 so it's relatively prime. How many x's can we pull out of this expression?
3.
3. You can only remove the smaller amount, right?
Right.
Then we'd have 4 minus 5x squared or something like that. Always smallest. That principle applies here as well. Here we have 2m minus b to the 1/2, and we also have a 2m minus b to the negative 1/2. So we have to remove the smallest. We have to remove the negative 1/2. So then there's a question. What happens if we remove a negative 1/2 from a positive 1/2? What's left over?
It will be n.
It's actually the whole thing, 2m minus b.
The parentheses should go away.
Yeah, you don't need the parentheses anymore. Plus,
Plus n.
m. There you go. And then we can rewrite this to simplify it one more step. We can move the negative 1/2 exponent term factor to the denominator there. And put it back in its radical. B. And then left on top would be, well, we can combine the 2m plus the m and get a 3m minus b. How does that sound?
Um, so it'll be 3m minus b over 2m minus b. I mean, well, we switch it back to the square root.
Right.
And we don't need parentheses for the square root.
Right. We don't need parentheses as long as you make sure that your line on the square root goes far enough out so that you can see that everything's in there. If you wanted to put this whole thing inside of parentheses underneath the square root, that'd be perfectly fine as well. That's just because of the simplification. Radicals always make things nasty with fractional exponents and stuff like that.
So when we choose -1/2 because it's the smallest number, and also you can always move it to the bottom.
Right. Yeah. So since we basically what we did here, if you could write it another, you could think of it another way in that we're making a common denominator. That's really what we did here. Is we can think of it as two fractions, and we make a common denominator by factoring out that -1/2. Yeah, it's pretty interesting stuff.